Hello, I'm Yasir. Today I will present some applications of linear equations. The first example I will bring the question. That's actually a example from the book. And I also bring the table which is attached with this example. The table is this one. So there are three sectors: coal, electric, and steel. So it says that suppose that an economy consists of the coal, electric power, and steel sector, and the output of each sector is distributed among the various sectors as shown in table one on where the entries in a column represent the fractional part of a sector's total output. So here it says that coal coal is taking nothing from its own sector from sector. It's taking zero point 0.4 of the output, zero point 0.4 of the electric output. It's taking zero point 0.4 of the electric output, zero point 0.6 of the steel output. Coal is taking these two things. And then it's the electric sector is taking zero point 0.6 of zero point 0.6 of the coal output, zero point 0.1 of the electric output, and zero point 0.2 of the steel output. And similarly, the steel is taking zero point 0.4 of the coal output, zero point 0.5 of the electric output, and zero point 0.2 of the steel output. So suppose that suppose that the output of coal is represented by PC and the output of electric is represented by PE and output of steel is represented by PS. Now, the total output of coal is equal to uh, that's output, and what will be the input? The output and input should be equal. So PC is the total output of the coal sector. And what is the input of the coal? The input of the coal is zero point 0.4 of the zero point 0.4 of the electric sector and zero point 0.6 of the zero point 0.6 of the steel sector. So that's output of coal, and this is the input of coal. So input is equal to output, so that's why PC is equal to these two. Now I just rearrange these. So if I rearrange, so that would become minus PC, the output of coal, and then plus 0.4 PE, and then 0.6 PS, and that equal to 0. Now, what about the second equation? Second equation is the output of the electric sector. The output of the electric sector is its inputs are 0.6 of the coal, 0.6 of the coal plus 0.1 of the electric sector, output of the electric sector, and 0.2 output of the steel sector. So if I rearrange, so it would become 0.6 of the coal and then no 0.1 minus 1 because here the coefficient is 1. If I bring this thing on the other side, So that would become 0.1 minus 1. So that would be a minus 0.9, minus 0.9 output of the electric sector, and plus 0.2 output of the steel sector is equal to 0. This is the other equation. Now the third equation. Third equation is that the output of the steel sector, you can use this rule. The third one, so it can be written as 0.4, 0.4 of the coal plus 0.5 of the electric sector, and then output of the electric sector, and then 0.2 for the output of steel sector. Now this thing can be, if I bring PS over other side, so first I write the 0.4 PC, and then 0.5 minus 1 would be minus 0.5. 0.5 P, oh sorry, uh, it will, because it is output of the steel sector, so it's here. So I will write these two quantities same as it is. So 0.5 output of electric sector, and then 0.2 minus 1, that would be a minus 0.8. Minus 0.8. Yes. So now these are the three equations and three unknowns. So one equation is this one. Second equation is this one. And third equation is this one. And these equations will be solved. So first I write into the augmented matrix form. So the coefficient here of PC is -1. So -1 would be here, and then 0.4, and then coefficient of P and the coefficient of PS is 0.6. And you can also write 1 here, 0 here as well. For the second equation, it is the coefficient of PC is 0.6. That's 0.6, and then coefficient of P is negative 0.9. Coefficient of PS is 0.2. Remember this thing, when you put it into the matrix form, you have to arrange in such a way that if you write PC first, then in every equation PC would remain first. If P is considered to be second, then in every equation you will have P as a second second number or second quantity. If PS is the third quantity, then in every equation you will consider PS as the third quantity, and then write in this way. And now for the third one, it is 0.6 PS, and then 0.2 PS, and minus 0.8 PS is equal to 0. So that's a matrix, and this matrix can be reduced into the echelon form. So in echelon form, you can put it, and then you can find the values for PC, PE, and PS. So you can put it into echelon form, and finally you can get this kind of form. You can get this kind of form. And after getting this, what you can do, you can write back into the quantities form. So here the first number is multiplying with PC. This column was for PC, this column was for PE, Second variable was PE and the third variable was PS in each equation. So similarly here. So this number, this entry will multiply with PC. So 0 times PC would be 0. This quantity, the second quantity in second, so that will multiply with PE. So 1 into PE and then minus 0.85, 0.85. There the third entry will multiply with PS. And this is the right hand side on, so that equals 0. So that's a one equation. And then from the first row, I didn't write any equation from the third row because all the entries in the third row are 0. So 0 equal to 0. So there will be no equation that will be of this kind of form. So no, from the first equation, no, from the first row, 1 will multiply with P, PC. Second, 0 will multiply with P, E, and then 0.94 will be multiplied with PS, and that equals 0. And now I can find PE from the first equation and PC from the third equation. If I find PC, so this quantity is 0, and I bring this whole thing on the other side. So PC is equal to 0.94 PS, and this quantity, if I put it, if I bring this whole thing on the right hand side, so that would be PE is equal to 0.85 PS. No, because there are three variables. There were three variables. One was PC, other was PE, and third was PS. Now the vector containing these three variables, that equal to what? So what is PC equal to? PC equal to 0.94 PS. 0.94 PS. And PE is equal to 0.85. 0.85 PS. And PS is the free variable because the third row was 0. So that would be a free variable. So from here, if I, because PS is common, so I bring it outside of the vector. So inside the vector, so one quantity is 0.94, other is 0.85, and the third is 1. So that's the solution of the system. Now I can choose any value for PS. If I choose any value for PS, I can get the values of PC and PE as well. So that depends on the value of PS. So that was our first example for the applications of linear equation. Now I will bring second example for applications of linear equation. In the second example, that's a balancing of chemical equations. So suppose that there is a chemical equation. So look at this equation. So in this equation, the one thing is clear that there are total three kind of atoms. One is carbon, other is hydrogen, and the third is oxygen. There are three kind of atoms. So you have to what in balancing equation you have to find out x1 which number will multiply with this molecule, which number will multiply with this molecule, and you get these two. Which number will be here and which number will be here. So total item on the left hand side should be equal to total item on the right hand side for each for each category, for each carbon, hydrogen, and oxygen atoms. So total atom on the left side equal to total atom on the right hand side. So for doing that, it was supposed that x1 is the coefficient of this. So this bracket will be considered as just multiplication. So X3 is multiplying with CO2. So for handling this kind of situation, so there will be four vectors. In these four vectors, so in the first, there will be a number of carbon atoms, then number of hydrogen atoms, and then the third place would be the number of oxygen atoms. And for the first molecule on the left side, this molecule, there are three carbon atoms, eight hydrogen atoms, and zero oxygen. There is no oxygen atom here in the first one. And in the second one, there is only oxygen, two atoms. So for that, carbon is zero, oxygen two atoms, and sorry, hydrogen zero, and carbon two atoms. So zero, zero. And from the right side, so here this thing would be first entry for carbon. But in every vector, the first entry for carbon, second for hydrogen, and the third for oxygen. So carbon, here the carbon is 1. And then the hydrogen, there is no hydrogen atom here, so that would be a 0. And there are two oxygen atoms, so there will be 2 here. And then for the fourth quantity, for the fourth molecule, first one is there is no carbon here, and then there are 2 hydrogen atoms, and then there is 1 oxygen atom. So these are the four vectors. So these four vectors can be written into the equation form. How to write that? So this thing, the first will multiply with x1. The first will multiply with x1 plus second will multiply with x2, and this equal to x3 plus x4. Now I can write it. I can bring the right hand side into the. I can bring these whole things on the left hand side. So 3, 8, 0 plus x2, 0, 0, 2 minus x3, 1, 0, 2, and then minus x4. X4 is 0 to 1 is equal to 0, 0. Now here I will write the first column. I write into the augmented matrix. So this is 380. This would be 0, 0, 2. This is negative 1, 0, negative 2. This would be a 0, negative 2, and negative 1. And then 0, 0. So from here, you can put into the echelon form. After reducing it into the echelon form, you can find the values of x1, x2, x3, and x4. So, so here x4 would be the free parameter. The last row would become completely 0. And so these are the variables. In echelon form, you can either you make it one or not. So, but you uh, must converting this non-zero entry to the zero entry here beneath this entry. So, and then because this would be the first pivot, and then here would be the second pivot for non-zero, if it is non-zero, and it would be a non-zero. And the third row would become completely zero. So that would be the here here the second position, second pivot, and this entry must be zero. And if this entry would be zero, so all entries here, it will be zero at the end. So only you would have this kind of, uh, so you will get x1, x2, x3, and x4 values from this uh, part of the matrix. So x1 is equal to 1 by 4 x4, x2 is equal to 5 by 4 x4, x3 is equal to 3 by 4 x4. So here, remember that because x1, x2 should be integer 1, 2, 3, not decimal, because the atom cannot be half atom, one and a half atom, so cannot be in the fraction form. So to reduce into the integer form, you can choose the value of x4 is equal to multiple of 4. Suppose that x4 is 4. If x4 is 4, then the x1 would be 1, x2 would become 5, and x3 would become 3 if x4 is 4. So you can use these x1, x2, and x3 uh, to balance the chemical equation. So because there will be infinite numbers, because this solution says that there can be infinite number. So you choose those number, and then that equation can be balanced, the chemical equation. So chemical equation can be balanced by infinite, by choosing infinite number, by choosing infinite possibilities. So yeah, so one of the possibilities that you choose x4, the value of x4 would be 4, and then you can find the value of x1, x2, x3. So that was the example in balancing chemical equations of the example, the application of linear equations. The next one is the flow, the traffic flow. The traffic flow. The network in figure 2 shows the traffic flow in vehicles per hour over several one-way streets in downtown Baltimore during a typical early afternoon. Determine the journey flow pattern for the. So that's a network problem. So here, so here you can see the corner, these points where the roads intersect with the other road. So these are the 4 points. One here, second here, third here, and fourth here. And here in these 4 points, the input flow is equal to the output flow. You will see that here arrow is going in this direction, arrow is going in this direction. So it means that these number of vehicles are coming to this point, to point A, and then these arrow sign means that the vehicles are going away from this point. So input is equal to the output. So you will use that the input flow is equal to the output flow. So using this thing in each of this point, and you will get the equation. So here the first equation can be 300 plus 500 is equal to x1 plus x2. 300, 300 plus 500 is equal to x1. This is x1 and this is x2. x1 plus x2. x1 plus x2. And on point B, it would be x3 is leaving and 300. These two are leaving. So 300 x3 plus 300. And what is coming in? The coming in are x2 and x4. x2 plus x. Similarly, on point C, the incoming traffic is 100 and 400. 100 plus 400 is equal to uh, going out. So it's x5 plus x4 plus x5. x4 plus x5. And similarly on this point, on point D, it will be input is x1 and x5, x1 and x5 is equal to 600. Is equal to 600. So from here, how many equations and how many unknowns are there? So that can be put into the augmented matrix form. I think it can you can solve it without uh, no, it can be reduced into the string form. So here, this is the first row, this is the second one, this is the third one, and this is the fourth. So you can put into the augmented matrix form and then try to find x1, x2, x3, x4, and x5. So that was the example in network flow. So here x5 would be the free variable. So there will be infinite solution for these equations. So there is infinite solution. You can choose the value of x5 and then you'll get the values of x1, x2, x3, and x4. So here you can find x1 is equal to 600 minus x5, x2 is equal to 200 plus x5, x3 is equal to 400, and x4. You can choose any value for x5 with any value for x5, and you will get that x1, x2, x3, x4. But remember that the x5 should be the integer, because the half vehicle is not possible, or one and a half vehicle, that's also not possible. So it should be in integer form. So one, two, three, four, positive integer, or the natural number, you can say that. I'm not going into the other part of the equation to solve reduce the matrix into echelon form. I'm not going in that topic. So I've just explained some of the applications of linear equation. So that can be done. That can be done. It's contains some calculations, some time consuming process as well. So that would be the different topic to reduce any matrix into the echelon form. Here my main focus is on the application. So yeah. Actually, it contains calculation. I will try to present that kind of part in like one of the later videos. So here Kirchhoff's voltage law. What it says that find the currents in the circuit. So there are three loops in one circuit. So linear equation have example in the circuit form. So there are three loops. So this is the resistor. This is the resistor. This is the battery. This is the resistor, and this is the resistor. And the current is flowing anti-clockwise direction. It is flowing anti-clockwise here. So here in this wire, it is going in this way. In this wire, it is going in this way. In this wire, it is going in this way. And in this wire, it is going in this way for I1. And for I2, for I2, for I2, it is going in this way, and then in this way, then in this way, and then in this way. So this is for I2. And then for I3, it is going this direction, this one, and this one. So anti-clockwise direction in all the loops. So I will apply the Kirchhoff, and here in the book it is applied, the Kirchhoff voltage law. The algebraic sum of the Ri voltage drops in one direction around a loop equals the algebraic sum of the voltage sources. Voltage sources would be a battery, here in this case, in the same direction around the loop. So voltage drop and voltage sources would be the same in each loop. So here in for the first loop for I1, for I1 the voltage can be what would be the voltage drop in here, here, and here. So I will add all the resistance. So 4 plus 4, 8, 8 plus 3, 11. So 11 I1. Here, look at that. Here current is going in this direction, in this direction. In this wire, for I1, it is going in this way. But for I2 in this wire, it is going in this way. Because I2 is also flowing in this wire. So it can be because the both have the opposite direction. So that I will use a negative sign with I2. So I2 would be a 3 because here there is only one resistor. So which has capacity 3 omega. Not capacity, I would say the resistance would be 3 pi omega. So here, that would be a 3 into I2, and this equal to the 30 volt. Battery is applied, so that equal to 30. And in the second loop, I will use 1 plus 1, 2, 2 plus 3, 5, 5 plus 1, 6. So 6 I2, that would be a positive. But because in this wire, I1 is flowing, but the opposite in the opposite direction. So that would be a 3 I1. And in the third, and here in third loop, I3 is flowing in this direction. So it will be subtracted again here, I3. And this equals to the battery. The battery here the battery is 5 volts, so that equal to 5. So this is the second equation. And for the third equation, for the third equation, uh, current is flowing in this direction. So here it is flowing in this direction, and for I2 flowing in this direction. So that would be minus I2, and then how much I3 here? 1 plus 1, 2, 2 plus 1, 3. So it's 3 I3 is equal to, no, look at it. Here in this battery current is flowing in this direction, but here for I3 current is flowing from in this direction from the battery. So this has the opposite direction than the previous one. So I will use minus 5 this and 20 this, so minus 25. So these are the three equation and three variable. You can solve these three equation and then try to find the values of I1, I2, and I3. So using the echelon matrix form, you can solve it and then you can find its solution. So today I end the class at this stage. So bye.